Hi, welcome to Database Development and Design for Raritan Valley Community College. This is Dr. Larson. This was our SQL lesson for this week. We're going to be Introduction to Joins. Actually, I should write that down. Some introduction. Uh, Now, joins are probably this for some people. This is one of the trickier parts when you first start learning SQL. But joins are fundamental to the concept of your relational database. So the first thing I want you to do is go ahead, go to the site. I'll pop the link in there. You're going to go into week 4, download the tables build and joins instructions. Okay. And then we're going to go ahead and open up the table build. Actually, hold on. I'm sorry. Where was I? Make sure you can see. I got the bad one. All right. Let me get this back up. All right. So week 4 down here. So this is my website. Analytics for all, and you're going to scroll down again, week 4, tables build, joins instructions. If you get lost, if on the link, it's just under free courses, and you scroll down to here, files for database development, design labs. Okay, so again, down week 4, then week 4, if I pull it up, it is right here, and again, we started off with, I got a couple links here saying if it's a problem, delete. Once we start getting, this is going to be our first example where we actually have the tables connected with keys. I'm going to briefly go over it. We're going to get really deep into keys in a little bit, but later. But this is what we need just to kind of, number one, just go over for the lab. You're also going to need this just for the conversation we're about to have. So I'm going to go ahead, pull this up. I'm going to open up a new query window. We're going to paste what I've got here. Go to the top. First thing first, always make sure you put in your database. So I say use DDD is the one I created, semicolons were there. Again, these things are all set, saying if this object is not null, so if it exists, drop the table, drop the table. This is just a statement. And again, this allows you to run it however you want. We're gonna get, this is interesting. This has to be shut down in a certain order, and we'll explain later. But what we've got here is the entire concept of relational databases. And I'm going to go ahead and, I'm going to start with the slides and I'll come back to this real quick. So I'm just going to go to the slide deck real fast. And I'm going to come back and we'll explain the keys a little bit here. So let's start with, so why do we need joins? Okay, and this is going to be the tables I've got. So we'll get into this. So let's say we have 2 tables below, student and billing. Now the billing table has information on the bills for the students, but notice that you're looking at the billing table alone, we cannot see the name of the student. So we have an invoice number, I have a date, I have an amount, is it overdue, and I have a student ID. I have a number. I have no idea how to map this to the thing. What you'd have to do is go ahead and into the student table. So the student table has a list too, it's IDs, and you'll notice they match up. So 234 is Kelly. So this bill right here, number 28, belongs to Kelly. 546 is Gary. He's not in this list. He must not have a bill. 643, that is our friend Gerald. And we got Lauren. She's got a couple. Kelly is the second one down here. All right. So what these are called here, this right here, this student ID and this invoice ID, these are what's known as primary keys. I'm going to write this down. You're going to get so sick of hearing about keys, but I'm just going to, take a moment. We'll call the primary key. Now, a primary key is a unique identifier. And this is what allows us to know that this column or every element in this column is unique. You use unique identifiers all the time. You just don't think about it. Your student ID, and if you're RBCC, it's your G number, your driver's license number, your passport number, your social security number, or your tax ID. If you're not American, if you're living here, you have a tax ID number that's unique to you. And so those are all primary keys. The rules of a primary key, which would be this column and this column, is it has to be unique. So you can't, what good is a driver's license number if you have 2 different numbers? If you have the 2 numbers that are the same, that doesn't help at all. You can't have 2 IDs that are the same. That wouldn't help you identify. Because, you can have names that are the same. We can have more than one Kelly. We just have to have an ID to separate which one's which. And then the other rule is can't be null. It has to be there. Okay, that's the main 2 rules, primary key. We'll get into other stuff more, but right now, just keep that in mind. So it has to be populated and it has to be unique. All right. Now, what we have here, the student ID over here in the billing table references our student table. Okay. This column references our student table. That column is what's known as our foreign key. Okay, so our foreign keys reference another table. Okay, so the rules of a foreign key is the main constraint in a foreign key is what's called referential integrity. Referential integrity, I'm probably spelling it wrong. Integrity. Okay. And what referential integrity means is I cannot have a number in this table, in this billing table, in this column that does not exist here. Like I could not put 123 as a student ID because there is no 123 student ID in here. So a table that references another table that has to have integrity. So this table has to know what's in this table to make sure that when you're putting something in here that it exists here. And because of that, when we create these tables, if you notice this one, we have our student table. Here's our primary key, student ID, the one we just looked at. We have a tutor table, which we'll get into the lab. There's our primary key is our tutor ID. Then we have a tutoring table, which again we'll get in as our primary key. This references as two foreign keys. It references the tutor ID in this table and the student ID in this table. And then we have the billing table I was just showing you, which billing invoice is your primary key. This references your student ID. Okay. So your student ID is what references this table. So that means when you got to go delete these tables, once they've been created, once they're created, if you try to delete them out of order, you're going to get errors. So I'll even show you this. I'm going to create all these tables. Okay, they're all created. Now watch, I'm going to try to drop the student table. Couldn't drop it because it's referenced by a foreign key constraint. Again, don't let this beat you up too much. Just keep this in mind. So what this does here, let me get this over for you. So again, the main thing, if I go back and I'm showing you, I don't know if you saw earlier, I think I was off camera. But so again, this table billing references our primary key, which is our student ID here. Okay, so it references the student. It tells you right there. It says it references student and the study, and that's what it references. So in order to delete it, I have to delete the tables that reference first. So I have to get rid of the referenced IDs first. And that's just the way it goes. So if I go up here and I start with these here, so I can delete billing first. If I drop billing, that works fine. Now I can delete student. Actually, I probably can't because it's still referenced in this tutoring table, even though we haven't used it. But there we go. So I got to delete them both. So that's the order as to why I'm deleting everything up here versus the earlier stuff you saw. I'd put the delete right in front of the table creation. But again, we're going to get way into creating tables and inserting. Don't worry too much about it. Just the main thing for you, put this in your database. You should be able to hit execute, and it should actually make sure populated. And you should get population where it should tell you you've got, where are we at? Sorry, 1 second, trying to grab this. So to show you got 4 tables were created. Those are your 4 tables. All right, got that, we're good. Let's go ahead back to our slide deck now and see if I can follow along. All right, so why do we need joins? That's the reason why we need joins. So I can see what's in another table we're referencing. So we can join that, and that is the whole point of our relational database, because this table via this column is related to this table via its primary key. Okay, that's the relation in relational databases. Okay, so in order for us to see, like I said, whose invoice is 23, we have to perform a join. That allows us to connect the primary and foreign key relationship. This is the basis of our data model. Okay, so again, these are our primary keys. That can be either a column or they can be a group of columns. We'll get into that later, but they ensure uniqueness of a record. And here's again the examples I showed before. Note the primary key, stud ID, and billing table, its invoice is their primary key. Okay, so primary keys have a couple of rules we call constraints. I went over some of these. There are no duplicate values, no nulls, no missing values, and tables can only have one primary key. A primary key can be more than one column, but we'll get into that later. But a table can only have one primary key. Okay. So foreign key, what we need, this is our foreign key, and our foreign key is in the billing table. Its purpose is to provide a matching column for the primary key to join, which I kind of already went on to explain, but I have a tendency of doing that. And the main constraint for our foreign key is it must have a matching data type to the primary key. So it's got to be the same data type. This can't be a string and this is an integer. And it must only contain values found in the primary keys table. So this foreign key could not contain 1, 2, 3 since it's not present in the table. All right, that's your foreign key. Okay, so when we bring them together, the tables together in a join, we can get a result like this. So now we have our billing and I've got a name instead. This is much more human readable to me, okay? So now instead of a number, when I join, I've got a name. And let's go ahead and let's discuss how we join now, okay? So we're gonna work just to allow you to multiple queries table in order to join, okay, so, sorry. Joins allow you to query multiple tables at once. In order for the join to work, you have to have a relationship. And you can see here, I've got a relationship built in. And you notice I have my keys are lit up here. And this is actually created in, I'm going to show you, it's created in SQL Server real quick. I'll show you how to do it. If you're in your SQL Server, let me go ahead and change my thing. You can go over to your database, okay, which here's my database, DDD, and I go right here to database diagrams and I hit new diagram. You might get an error first time you do it. Does not have one or more support objects required. If you wish to create them, you say yes. You know, that's it. Just say yeah. Sometimes you get it when you first try it. Sometimes you don't. It's depending on Microsoft's mood that day. So let's just pick the two. We'll go to billing and I'll hold the control key and I'll hit student and I'll add them both. And you can see when I do this, they are connected. I have a connected wire. See, if I did this with some other ones, let's just for fun, let me show you another one here. Let's do our sports stats and our vet visits. They're not connected in any way. So what you when you get those two come up, close this out. Eventually, you get this. There's nothing. It's blank. So there's no connection. That means these two don't have a relationship. Okay. These two are related. They're related. You can see the primary key. In fact, when you look over here in the columns, if you go to, I got to refresh my tables here. Refresh. It's a Microsoft thing, you know. Go down to here to, if I look at my billing, you're going to see I've got, this shows you my primary key, and this will show you my foreign key. It even tells you what they are, okay? And I go to here, and I go to student, and I've got my primary key, no foreign key in that one. So it's a good way to see there, you know, that way you make sure what you ran works correctly. But all right, so that's good enough for that. I can close these out. We don't need these diagrams anymore. I don't want to save it. Don't want to save that one either. All right, so created the tables. We're good here. Let's go ahead back to our deck. And that was the whole point. So they have to be related for this to work. Now, once we have that, we have tables that are related, we can join. Okay, so we join. We have 4 joins we're going to go over. 4 joins are the inner join. We're going to have a full outer, a left, and a right outer. We're going to start with the inner join. The inner join is the default join in most databases. In SQL Server, it absolutely is the default join. What that means is when you type it in, you don't have to actually use the word inner. If you look here at the syntax, all I have is the word join, okay? Sorry, move my thing around. All right, so let's start with what the inner join does. The inner join does is it takes over only things, it only brings over stuff that matches. So here I have a table A, which has ID columns of A, B, C, D. Then I have a table B, which has A, C, E, F. And when I join these two tables together, all I get is A and C, because these are the only things that exist in both tables. B and D does not exist here, and E and F does not exist here. So only A and C come over. So that's what inner join does. It only brings over matching information, okay? So the syntax for join is very simple. You say select whatever you got from table, and here I'm aliasing my tables. And the reason I'm aliasing my tables is if I don't, I would have down here, I'd have to write table A and table B. And when you do this a bunch of times, it gets really tiresome. So sometimes it's easy just to label. I do advise you use an alias that makes sense, because when you're trying to look back on massive lines of code, this gets really ugly. But anyway, so we say select from table A as A, then I join my next table. So table B as B. And this join has a separate section. Now notice we have another keyword called on. On IDs. We're joining on these columns. So these are the two columns we're joining against, okay? A and B, okay? So that's it. So I'm joining the ID column from A to the ID column from B, okay? That's the basic. I know this doesn't look like I'm just trying to make a very simple example here. When we get to the other ones, I'll show you what more realistic examples look like, okay? So the results for our student thing go like this. Shoot. All right, so here's an example in our table here. So again, we're looking at our student table and our billing table. So we got our student billing. Also notice as I'm aliasing these S and B up here, I'm trying to let you know which column the table comes from, which, you don't have to all the time. The only time you have to do it's when they have the same column name in two tables, then you'll end up with a problem. But this, trust me, when you're making massive SQL queries with a lot of table joins, it's much easier to just quickly look and tell which column which table this column is coming from. So anyways, we sit there and say, select star from student, join billing as B on stud ID, S stud ID equals B stud ID. So again, that's what we're joining on is the primary and foreign keys from these two tables, and we're returning these values, okay? And you get this result out here. If I went and wanted to do it really fast here in our SQL environment, just to show you, I could create a new query, and I could sit there. Number one, you could sit there and just say select star from student as S, join billing as B on S dot stud ID equals B dot stud ID. And there you go. Again, ignore this red stuff. It's Microsoft, but it works. You get everything. What you'll see is you get everything. So I've got everything from the first table and I got everything from the second table. But that's not what I want. I wanted that from all I wanted was everything from the B table minus the stud ID. I wanted to replace that with the student name. So what I did in the other verse, now watch, I'm going to show you, I can do this without actually putting the B in front. And it'll work. I can say invoice date, amount, overdue, and then I just say stud name. Okay, I can do all this without putting the A and the B in front of it or the S and B in front of the aliasing because they don't exist in either table. However, if I tried to do this, stud ID, which exists in both tables, now when I try this, I end up with a ambiguous column name, stud ID. We don't know which table you want me to pull that from, okay? So again, you don't need to unless it's in both, but trust me, you will thank yourself later in life if you make it a habit of doing this, because now you can just really quickly look at your code and you know exactly which table this all comes from. All right, so execute there, and there we go. And that's the results we get. Let's go back to our slide deck. Okay. So that's the idea behind an inner join. Again, the inner join will only bring, notice for our inner join, there is no Gary, okay? In fact, I was going to show you that in the next slide. Gary doesn't exist in the inner join results because Gary does not exist in the billing table. Remember, we go back to the billing table. Gary's 546. There is no 546 in the student ID column in the foreign key. So Gary's not going to show up. Again, the inner join only brings over things that exist in both sides. Next, we have what's called a full outer join. Okay, a full outer join is the exact opposite. Now, again, this is correct to write it. You do not actually have to write the word outer, though, because it knows full is an outer join. So that's fine with that. So, but this one returns everything. So again, I'm just using the star in this example, but you'll notice you get some nulls here. These nulls are Gary, because Gary has no invoices in that ID. He exists only, he doesn't have an invoice, so he doesn't have any information in this column. So he shows up, comes back to the table with a null. All right, so that's your full outer. Full outer takes everything from both. So you can see A, B, C, D, E, F, and it returns nulls where values don't exist. So in the first table A, there is no EF, and in this table, there is no BC, so BD, I mean. So that's where you get the nulls, and that's where the null comes from here. So that's your full outer, pretty much the opposite of your inner. Okay, now we have your left and your right outer. Okay, so your left outer takes all the data from the left table, which in the phrase comes, if you think about, if you actually sat there and did, let me just go to back to our SQL friend here. So if I did this, because again, SQL does not require you to be on multiple lines. You make the lines for it easier for yourself. But this is where SQL comes from. They view it all on one line. So they call the left table the first one you're right, and the right table is the second one, based on this moment right here. So I know it may look a little different when you see it like that, but it's the first table is your left. Okay. So in your left outer join, you have everything from the left table. So A, B, C, D, and only stuff that comes over from, only stuff that matches from the right table. So you'll see here, you got everything A, B, C, D, then you get nulls here for B and D. E and F do not appear, okay, because they are not in this table. Right outer, exact opposite. Takes everything from this table and what comes over. So that way you get A, C, E, F. So right outer, left outer, exact opposite of each other. Most people will pick one they like, and only, I've never used a right outer and outside of academia in my life. I just stick to left outers, but that's just me, and fine, most people will have their way. But when you write it out here, so this is an example, left outer join, you know. But I wanted to show you again, when you get in here, if you wanted to do a join, so let's say I got this one, let me go back and just make it easier. Go to here, and I'm going to do a full join. Now again, you do not need to write the word outer. It knows full, so that returns our full, and there's our, hold on, sorry. So you can see what I wrote. I'm sorry, I'm talking to myself. But I did a full instead. I took our earlier join and just put the word full in front of it. So this was the, so all I did is I took this and wrote the word full in, and then I ran this, and I got this. And now I got the nulls. And if I wanted a left join, I can just go here. I get a left join. That again returns our nulls. And if I do a right join, I shouldn't have any nulls because the right join is only going to start with the billing table. It will ignore the fact that there is a Gary and there is no nulls. All right. There we go. That's it for the lesson. I'll see you back for the lab walkthrough in a couple minutes.